Do you know what we plugged in for audio? Which cord coming out of the hole? Which cord? Oh, okay.
Yeah, it's on the VGA dongle.
He didn't turn that on. So was that supposed to come out over here, or was it supposed to come out over here?
It comes out over there, but you have to unmute him. Well, he has to talk for you to hear something. We can unmute us and talk to him, though. Unmute Neil.
Oh, sorry. Okay.
Manoj?
Can you hear us? Manoj, can you hear us?
Yes, I can hear you.
Okay.
Can you hear me?
Yes, we can hear you. Let me put I'm gonna put me on mute for a second because I'm getting a little feedback in the room.
Okay.
Okay. Still getting feedback, huh? Is that your laptop, James? You got the microphone on? Still getting some feedback. Or is that from this recording microphone here? Okay, let me just turn this off.
Can you see my screen as well? Okay. Okay. Yeah. Excellent. Thank you. Yes, thanks for the introduction. Yeah, my name is Manoj Kumar. I work at IBM. I'm the chief engineer for OpenStack and OpenShift on Power. And I've been playing around with running Power AI directly on OpenShift. And sort of the premise behind this, or sort of the background, is that these systems with GPUs are sort of precious resources, and they have to be sort of deployed in a cloud model for efficient use, reuse, and sharing, among the community that wants to access them. So a cloud kind of deployment model kind of makes sense, and OpenShift with this sort of container technology is a good way of sharing those kind of precious resources, sharing the GPU resources. And the approach then is really to deploy something like Power AI, or it's something you build on top of it, using these frameworks to be run in a sort of a container format, and OpenShift provides sort of that Kubernetes environment to kind of dynamically provision and place these kind of workloads. schedule them, and when they're done, kind of tear them down so those resources are available for others. Am I coming through okay in the lab? And can I? Okay, excellent. Okay. So what I thought I would do is spend a few minutes doing a demo of the kind of things that I've been doing. First, James and others would have talked to you yesterday, and you probably also did a lab earlier today about Power AI Base and TensorFlow. So this is our, IBM Power AI Docker Hub, and that shows all the tags for the various images that we have out there. A generic image, a specific image for TensorFlow, and any ones that have this underscore cloud as a postfix are really indicative of ones that you can deploy in a cloud environment. Earlier versions of Power AI ran the container as root, and that isn't really appropriate. So with our Power AI teams, made some changes where that root is no longer a requirement, and you can run these images as non-root, and that's really what that underscore cloud postfix is about. So there is TensorFlow, there's PyTorch, there's Caffe, and so on. SnapML. So that's the sort of the various frameworks available, and you've gotten through probably a good number of them during the lecture, and then as well as in the lab earlier today. So building or taking those, what I've done is, and I've shared this with Rob and Michael at BU, is that I've actually put out a GitHub location where I talk about what does it require to run Power AI on top of OpenShift. So it's under my GitHub, under Power AI Base on top of OpenShift project. And I go through some of the processes that you have to go through. And we've gone through most of these on the systems available at the Mass Open Cloud with those 9 or 10 servers. We've gotten this process mostly working. So what you basically do is you have to prepare your systems as documented in the Power AI documentation. This is mostly installing the NVIDIA and the CUDA stack. And then you have to go through this device plugin as documented in an OpenShift blog. Rob, I think, has completed this step as well. So there's this step 4 is really all kind of taken care of for you on these systems. And so has step 5, I believe. So on RHEL 7.6, you have to do some additional steps as well. Once you've done that, and if you clone this particular project, I have some templates for deploying Power AI Base on top of OpenShift, and I'll run through those as examples. So essentially those steps are, create your templates, and those template files are in the same project. Create a new project, create a service account, and set some security sort of policies, and then you can go ahead and have some additional templates for each one of those frameworks. So let's take a look at how that looks once these steps are completed on an OpenShift cluster. So I'm going to switch over to the OpenShift Web Console. This is now privately to my my OneNode cluster, which has some GPUs. So once those templates have been loaded, you can browse the catalog, and you would go look under the templates that have this Power AI. I didn't have a graphics person designing it, so I ended up borrowing icons from other projects that are already available in OpenShift. So you have the various frameworks, and I've created one template for each one of them, Cafe, Torch, and TensorFlow. So these can be done if you use that project that I just showed. So to deploy something like a TensorFlow base, what you will really be seeing is, and actually let me show you the template really quick as well. So the TensorFlow template, by the way, I don't know how well my screen is showing up there, so it's hard for me to tell. Okay, so the way that I've written this TensorFlow template is, go ahead and deploy that TensorFlow, Docker image from Power AI, but when it starts, go ahead and run the TensorFlow test. So it's really not that interesting, but it's just mostly for me to demonstrate that capability. So to accomplish that, I just click on that Power AI TensorFlow, and you're going to walk through the template. You'll specify how much memory you want. In this case, I'll probably want to say, it's a shared environment. I don't want to be too greedy, so I'll just take one GPU, pull my project from that OpenShift namespace. This is my version that I'm going to deploy, and just hit create. So it's really that simple once you have that template to deploy TensorFlow, in an OpenShift environment. So let's go now take a look at how that deployment is coming along. Power AI TensorFlow is being deployed. It should be spinning up here, in the next few seconds or so. And there you go. That one pod is up and running. As I said, this would be largely uninteresting because on start, all I'm doing is run the TensorFlow test, and that's what this is really showing. Is it's going through the process of running TensorFlow test on this environment. So as I said, not terribly interesting, but at least gives you some idea on how to run a Power AI based image on top of OpenShift. So let me go ahead and tear down that GPU resource. So I'll switch to the Project AI base project, and I'll go ahead and delete my deployment to essentially reclaim the resources so I can now deploy my next thing. Okay, any questions so far before I move on to the sort of next step? Yeah, absolutely. I could have gone here to the deployment. Yeah. What? Yep. Absolutely. So next, what I want to talk about is how you might use one of these Power AI base images to do something more interesting. And my demo is going to be based on something we at IBM have done, not from the Power team, but we have essentially a model asset exchange, which is a bunch of trained models. So it's very sort of consumer-friendly, ready-to-go models that have already been trained. And there are various kinds of, classification, segmentation kind of problems that the models have already been trained, and they're available in kind of a Docker format or containerized format. So we're going to take a look at one of those, which is this image caption generator, which essentially takes an image, takes a look at the image, and then tries to come up with a caption. So as I mentioned, this is available. If you go to this Max thing, you can look at those models. But what I've done essentially is clone that project, and instead of using the base image that Max uses, is to switch to a base image that is a Power AI image. So in this case, I know this caption generator uses TensorFlow, so I'm going to just use the TensorFlow IBM, provided IBM Power AI based base image. and then it does some additional pulling of the model, and then actually runs that application. So I'm going to demonstrate how that gets deployed in an OpenShift environment. So I'm going to view projects, and I've created a project already for the demo. And then similarly, I've created these templates, and these templates are available in my same project under these files called Max Image and Max Image Web App. So you'd have to, do an OC create with these files to get these templates loaded. So those templates went in, so you don't have to go through. Let me just click other over there. So the two that I'm going to focus on are the image captioning ones. Now, these image caption ones, as I said, have been tweaked to use the Power AI as the base image, and then does some additional model stuff on top of that. So the image caption one is fairly simple to deploy. It's already a trained model, and this one runs okay even without a GPU. So I'm going to leave the GPU limit at 0. I'm not going to take up any GPUs because this inferencing part of it doesn't really require GPUs. There are some other models that are retraining models where the models are already available, but you might fine-tweak them, and that might require a GPU. But for inferencing, in most cases, you don't really need a GPU. So I'm going to leave the GPU thing as 0 and just say create, and we should be able to see that Max model, the image captioning model being deployed. So it's very similar thing. You should be able to take a look. The model should be spinning up here real soon, and once that's up, you can see whether it's available at the, so it's running on port 5000 on that container. So in this case, what I've also done in my template is create a service and a route so I can access my that service, my web service. And it's a really simple, as I said, image caption generator built on top of Power AI base. So in this case, it's as I said, a fairly simplistic model to kind of test it out. And you could try this with these Max models directly from the website. But if you want to run them on Power, you would need my images. So I would say browse, and I would pick an image. In this case, let me go ahead and show you what that image was. It's a simple image. It's my sister visiting a farm in Australia, feeding a horse. So I just execute on that, and then it comes up with these a few captions for those: a woman standing next to a brown horse, a woman standing next to a horse in a field, a woman standing next to a horse in a corral. So that's sort of a simplistic demonstration of one of these model asset exchange already trained models and how easy it is to deploy on top of OpenShift. Yep. Yeah, I don't know. That's a good question. I don't know why the probabilities were so low. I think typically this particular model works well if there is only one object and one person. So yeah, that is a good question on why the probability. We can try it with other images as well. Yeah, exactly. Even with the low probability, the captions were very appropriate. Okay, so next what I want to show is, again, another one of those Max models is to show this as a web app. And, this was kind of a little manual process. So there is another template which I'm going to add on top of it, which is this web app that's built around this image captioning service. So for this, I would need to, it's sort of built on, I call this project 2. I'll need the web location of that service that's already running that I just deployed, and this is going to be something that builds on top of it. So that's running at 172 at whatever this IP address at port 5000. So I would specify that in my URL. So my template requires that IP address :5000. Again, since it's going to do inferencing, I'm not really going to do assign any GPUs to it. And so I'm going to say, go ahead and deploy that the web app on top of it. Again, this web app is another Docker image that I've changed to use Power AI sort of as the base image. Okay, so now let's take a look at the deployments. So this web app is sort of another service. It's spinning up. Let me take a look at the log. This one takes a few extra seconds because it has to connect to that the port that I gave it, where my captioning service is running, and now it's kind of ready to consume. Similarly, I've created a route in this particular case for my web app that builds on top, and this will take a few seconds again to kind of come up. And so now I have my sort of caption generator, a little more user-friendly kind of web app, and here there are a bunch of images that have been preloaded, with all those captions that have been generated for those images. But I could do a new image as well, and in this case I'm picking an image that I found just downloaded from the web. I said go ahead and submit, and it's this picture here. And the captions of the generations are, group of young children playing a game of soccer, group of young men, and so on, group of young boys playing soccer. So, these kind of trained models help kind of make this kind of more accessible. I mean, I'm not suggesting that the research community use it, but we do already have these assets, a whole bunch of assets that we have developed at IBM as available free models. So this could be, an audio classifier, a facial estimator. There's a whole bunch of models there that can run on top of Power AI with just a little bit of extra sort of work that I showed. Yeah. Yeah, I know. In this case, the web apps is just talking to the other. It takes an image, feeds that to the other, other service that I generated earlier. So, yeah, the web app is actually just connecting to the. Yeah. Oh, I see. Okay. So I think that kind of covers what I wanted to show as far as the demo and how you can do sort of, build both inferencing, and you can do it for training as well. And training is probably where it makes most sense to do it on Power. But how easy it is to take something, that's available and run it on top of OpenShift. So it's available in a cloud kind of environment where it's shared, and you can share those GPU resources instead of having to have an entire system or an entire cluster or rack to yourself. That's really where the value proposition is of something like OpenShift, where you can maybe multi-tenant, multi-user, multi-project, and many people can share this environment that we're building at VU. So that kind of wraps up what I wanted to show. Any other questions for me? No, I have not with distributed deep learning. I've just been doing these simple models. There might be some that might be a fit. You know, most of these are already trained models, but so if we pick one that requires some retraining or something else, that might make sense to do in a distributed fashion. I was showing inferencing because that's a lot easier to show and easier to compress into a short time frame that we have. But yeah, that's it. Okay. So yeah, there's a breast cancer mitosis detector, which is quite useful, and I've seen that have good predictability. I mean, good probability results from that. There's a whole bunch of models available that can be easily switched to running in this mode. Hey, Peter. Glad. Okay. I appreciate him joining and appreciated all his efforts at making this available. Yeah, this is probably the first time anyone at Red Hat is seeing this as well. So I'm glad that he's able to attend and participate. Okay. All right. Thank you.